Hello and welcome to LogRocket. Today I'm here with Nick Thompson, who is the creator of a really cool audio tool called Elementary Audio. And this is a special episode because it's our first ever video episode. We're going to be posting video from this episode on YouTube, but of course, audio will continue to live wherever you get your podcasts normally. And we may have some video only content here. So if you're listening to the podcast on audio, we will put a link to the YouTube for any kind of parts of the episode that are video focused so that you can check those out. But hey, how you doing, Nick?
Good. Happy to be here.
So, really excited to learn about what you're building. I know very little about audio, audio engineering or digital signal processing or any of these things. So I'm extra excited to learn from you.
Great. That's you are right in my target audience, so that's great.
So could you give us a quick overview of what Elementary is?
Sure. So Elementary is a new JavaScript runtime for writing native audio applications, and it's based on Node.js. So what you write kind of to work with Elementary looks a lot like what you would write to work with Node.js. So you can use npm install, the whole npm package ecosystem, etc. But when you invoke your application, you invoke it with the Elementary command line tool instead of the Node.js command line tool. And so the primary difference is that when you work inside Elementary, there's basically a native module, specific to Elementary that is able to interact with your JavaScript code on the front end and a real-time native audio rendering engine on the back end. So you work in JavaScript, but you can use this application to ship, native audio software. And the heart of the project is something you can embed in, native audio applications in custom native stacks if you have, that type of application.
And when you say like writing audio software, are we talking about like editing audio samples, or are we talking about digital music production, or both? What are kind of some of the common applications you see?
Sure. So I think that this can cover all sorts of different audio applications, like all of the types that you just mentioned. I think that you can do with Elementary. I'm personally kind of coming at it from the digital music production realm. Before I started this project, I started a company to make and sell audio plugins for computer musicians, and that was kind of what prompted this project. Actually, was just the process for building those products and getting them out in the market is difficult, takes a long time, easy to get wrong. And before I got into that field, I was a front-end web developer for several years. And I really missed the speed and the tooling and the workflow that you have in that environment. So anyways, kind of a tangent. But yes, you can handle all kinds of audio software, real-time, digital music production. I have somebody who's interested in working on kind of like a digital guitar pedal, picture like a guitar pedal with your, quarter ins and outs, but where the DSP is actually running via Elementary, which I think would be cool. So it can do a lot.
And typically this kind of software it would be written in like C++, or is that where a lot of the library support is?
Yeah, definitely.
And so what are the advantages of being able to write audio software in JavaScript?
I guess I look at it. Maybe this is the pessimistic way of looking at it, but in large part, I see the advantages as avoiding the disadvantages of working in C++. And to be honest, I think that the kind of standard approach to building audio software in C++, insofar as my experience has shown me, leaves developers to solve the same types of problems over and over again in ways that I don't think we really have to. For example, like we spend a lot of time building native audio processors that want to filter a signal in some way, or generate a signal in some way, or read from a file in some way. And as soon as you kind of kick that can of worms open in C++ land, you have to deal with multi-threading, lock-free interaction with the real-time rendering thread. You really want like deterministic operations to happen, like strictly deterministic on the real-time rendering threads. You have to be very careful about memory allocations and deallocations. And this problem kind of compounds pretty quickly. And I have not so far seen a lot of C++ solutions that kind of generically solve this once and for all. So for my own products and for companies that I've worked with, I found myself kind of like rewriting the same code to solve the same set of problems. And these are tricky problems also, like it takes a lot of time. So sorry, I'm rambling. But in a lot of ways, I think JavaScript has advantages here because we can work in a way that feels much more like React. So you can work in a way that has this dynamic, low barrier to entry language with this huge tooling ecosystem where you can work with like a declarative expression of what you ultimately want the sound to be, and kind of leave the rest to the elementary engine.
Yeah, so maybe on that note, could we jump into a demo and take a look at what it actually looks like to, write some audio in elementary?
Yeah, of course. So I want to start with basically a hello world of working in audio. And so, as I mentioned, this is going to be a lot like working in Node.js, right? So to start, we just open up a JavaScript file. And is my text rendering okay? Should I bump that up? I'll go a little bit up. Okay. All right, so this file here is just slightly more than the hello world, but I want to walk through it pretty briefly. So in the elementary environment, there's a global variable defined by the time your code will execute, which is called elementary. And your primary interface for working with elementary is through this object. It's kind of like the web audio API that you can reach from window in a browser. So we have this core, there's basically two pieces, a core module and a library module. The core module is a lot like an event emitter, onto which we have to subscribe for the load event. Also similar to the window load event in browser programming. Then what I want to make here is a really simple sine tone with an amplitude contour. So the amplitude contour is just going to be like a quick sort of pinging volume. What's the word I want? Volume shape. So to do that, we use the library function here, el.cycle, which will generate a sine tone here at 440 hertz. Then I use the el.train library method, which will generate a pulse signal, which is a signal that goes from 0 to 1, then back to 0, and then repeats at whatever frequency you specify. So here I'm going to run that signal at 2 hertz. That signal will trigger an envelope generator, and if you don't know, if you move to audio, envelope generator will be a foreign word to you. Maybe many of what I've said already will be a foreign word to you. But this generator is just a way to sort of smoothly get from 0 amplitude, which is silent, up to an amplitude of 1, which is kind of as loud as the incoming signal is going to be by the time we're at 1, because it's at the end of the day, we're going to multiply this envelope by the sine tone. And so at a gain value of 1, it's just the identity function. So the envelope will go smoothly from 0 to 1 and then back down to 0 over time. And this will be triggered every time our gate signal goes from 0 to 1. So all you need to know really is that we're approaching just a pinging tone sound, very simply. So we've put that together, and then here is the primary kind of render step. And this should feel a lot like React. So I'm describing what I want my signal to be, and then I'm asking elementary to render that signal. So just starting with that, if I then invoke this from the command line, just like you would with the Node.js script, we should hear our pinging tone. Make sense so far? Okay, let's take this one step further, but definitely stop me if I am failing to explain any of these things adequately. Okay, so what I want to show here is kind of a series of examples that arrives at a way of synthesizing like a kick drum sound. Think like kind of like a techno song with that like classic duh, 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 right? So synthesizing that is actually a pretty simple exercise, and I think it's fitting for a short podcast. So we're going to go kind of step by step on that route. So to get there, we have this pinging sine tone, right? And now a very simple way of synthesizing this type of kick drum sound is to get that tone every time it starts to sweep down from a higher pitch. So what I'm doing here is we have the same gate that we started with last time. So this is going to trigger at the same rate as the prior one. We have our same amplitude contour. So this is what gives it the each kind of instance of the kick drum. And then we have another envelope, exactly the same like signal function, but this time we're going to use it to modulate the pitch that the sine tone is running at. So then we're going to generate our tone, and to do this, we take our same sine tone, but instead of just running at 440 hertz like we were last time, we're going to add to that 440 hertz the result of multiplying our pitch envelope, basically so that it will go from 5 times 440 hertz down to 440 hertz itself very quickly. And then we take the result there, we multiply that tone via the volume envelope, and we ask Elementary to render it. So running this example, we're going to expect to hear like a pinging sine tone, but each time it pings, it's going to have this kind of like chirp at the beginning. Does that make sense?
Yeah, so you can kind of hear, I was going to say, like, you can kind of hear a bit more of the attack there, it sounds like.
Yeah, exactly. And so we can, like, for example, opening that same file back up, we have our pitch envelope, right? And the way this function works, the ADSR, this is a common kind of abstraction for envelope generators in DSP. So this is the term ADSR. It's something you could Google and read all about. But in general, we have like this first argument will be the time it takes to get from 0 to 1, the attack phase of the sound. Then the next value is the decay. This will be the time that it takes to get back down from 1 to some sustained value. That's the S in ADSR. And then we're going to hold at that sustained value until the gate releases, basically. And you could think of this as lifting your finger off of a piano key. And then the envelope will kind of ring out slowly back to 0. So we're using this to modulate the pitch of the sine tone, which means that we can just come in here and like tweak some values. For example, we have a quick attack in the pitch envelope, and if we change the decay time now, I'm going from 10 milliseconds here to 100 milliseconds. This might not be a terribly drastic change, but let's see what that sounds like. So now the chirp is kind of takes a little bit longer time. Okay, so example number 3. This is really the same thing that I just showed you, but we're going to take that whole process and just move it down to a lower pitch. So all of these, the idea of all of the envelope generators that we just worked through, that's all going to stay the same. The tone that we started with was previously running at 440 hertz with this sweep down from 5 times 440 hertz. I'm going to pull that down to 34 hertz because here we're getting into kind of like the sub-bass range. And so as we sweep down, we're going to get kind of the chirp or the click of our kick drum, and then it should kind of like ring through with a brief sub sound. And then the last thing that I've changed here is I'm taking that sound and I'm just saturating it slightly. This is like a subtle distortion. You could think like a guitar pedal type distortion, just to give it a little bit more character. So with just those few changes, we should hear something more like a consistent techno kick drum. So that is like the basic example of a really quick walkthrough from kind of hello world to synthesizing a sound that should hopefully be somewhat familiar. And I have two more examples if you want to go into it. We can skip them if you don't want to, but kind of leaping from hello world and kick drums to kind of a more complete kind of drum kit synthesis. What do you think? Go there or skip it?
Yeah, let's check it out.
All right. So I'm going to skip ahead away from just kick drum synthesis. And I'm going to show you really briefly here what it looks like to interact with MIDI. So I have a MIDI keyboard next to me. And as I'm pressing notes on the keyboard, I want to trigger drum samples. And these drum samples are all going to be synthesized in the same style that we just discussed. So I have a kick drum, a clap sound, and a hi-hat. And I want to show you down here, this is where elementary, I think, gets really interesting. So after the load event, we install a MIDI event handler. And when we receive a MIDI event, I have this function here, update voice state. And in a lot of ways, you can think about this kind of being like, are you guys familiar with in React and Redux, you have this kind of notion of like dispatching actions, and then the stores have their reducers to update state, and then the components listen to the stores, right? So this is really similar. So when we receive a MIDI event, I want to update some notion of kind of the application state. And then I want to use that state to render a new view of my application in a sense, except here the view is the description of the DSP. And once I have my new description of the DSP, I can just pass that to the render function just like you would do with React. And elementary under the hood will, just like React, diff the current state and the future state and make sure that we only make the necessary operations to get the underlying runtime to make those sounds. So really quickly, update voice state. When we get a MIDI note, we're just going to look at this voices array to see if the note we're receiving matches the MIDI note number in our map here. So I only want to interact with MIDI note numbers 60, 61, and 62. When we get that MIDI event, we'll find, for example, like, if I push MIDI note 60, then I want to go right into that voices array, a new gate value. This is going to be 1 and 0, just like the trigger for our previous example. And if you're letting go of the key, I'm going to go find that same note and set the gate to 0. So this is your on and your off. And once the state has finished updating, this right here is like the whole rendering pipeline, right? So we just look through each of the voices in our map, and we invoke their function with their new state, whether or not they're going to be on or off. Pass that to core.render, and if we run this, so we're not going to hear anything until I start pushing keys, right? That should be a kick drum. You hearing that? So right there in like, I don't know what that was, 50 lines of JavaScript or something, we have an interactive example with totally synthesized elements all in JavaScript. And each of those elements are synthesized just kind of the same way that we walked through with the kick drum. And actually, this whole library is available as an NPM package if you want to like NPM install and tweak your own application with it. So with that, I just wanted to show basically MIDI handling and the render step, how the render step can take a new description of the tree and get from A to B. And that's it. And that's the example.
Yeah, I mean, this is awesome and especially cool to see how much you can do with so few lines of code. So I'm curious, like we talked about replicating the sound of a kick drum. If you were to think about replicating a different sound, I don't know, a violin string or a trombone or like any instrument, what would be your process to take a sound sample and figure out how to replicate it in code?
I mean, there are whole fields of research that go into answering that question. And I very particularly chose a kick drum because there is like a sort of well-known kind of accepted approach for synthesizing a kick drum. And that's what I showed you. And actually, I even simplified it further. So, if you were to go get kind of an analog drum synthesizer at a Guitar Center or something like that, it's probably doing something more complicated than what I just showed you to try to simulate the sound of a kick drum. And there are like totally whole fields of research going into like how we can try to recreate the sound of a violin string accurately using DSP. And I'm definitely the wrong person to ask on that. So my process, honestly, is if I'm interested in synthesizing something, I just start with Googling it. I go out and I read about the existing research. And often the research is pretty intense, really interesting to read, but I don't know that, like some of it's even over my head, right? And so sometimes I like find research that I'm interested in and use that just sort of as inspiration for guiding my own synthesis approach, and see if I can get something that I'm happy with, whether or not that is close to what I was going for.
Got it. So not an easy answer there, but it's good
Yeah.
to see at least that like I imagine the previous articles or code samples that have been written for kind of the C++ tools, you could probably translate those fairly easily into what you're doing in JavaScript, right?
Yeah. Yeah, totally. And actually, I'm finding it even more. I'm finding it more enjoyable actually to write it in JavaScript. So, for example, one of the library features that you'll find in Elementary is an anti-aliased sawtooth oscillator, and basically that's just an oscillator that has this really sharp kind of aggressive sound, but will intentionally try to avoid aliasing in the digital audio spectrum, which is a whole conversation that we don't need to get into. But as I've written stuff in C++, I've written this approach in C++, and this particular approach that's in the Elementary library is called polyglot. And I've written it in C++. It's not so bad in C++. It's pretty easy, but I rewrote it in JavaScript using Elementary to add it to the library. And it just felt far more intuitive to me to think in that, because not only am I working in JavaScript in Elementary, but the declarative way of expressing these things to me feels much more intuitive. So, yeah, I don't know. It's been an interesting process.
One thing I was curious about, when I saw you writing, writing the code, and you were working in Vim. Any thoughts on like whether in the future there might be an IDE for writing code in Elementary? Like, it strikes me as the kind of thing where having an IDE that gives you, ways to quickly listen to just certain effects, or to drag a slider and hear how it changes the sound. Like, some of those things could be really cool in an IDE and make a programmer much more productive. Is that something you've ever thought about?
Yeah, absolutely. Some of the work that I'm hoping to get into this fall is basically building. I don't know if an IDE is the right word for it, but either building out like a desktop application environment for working in this kind of way. It'll either be a desktop app or a plugin that loads inside of your DAW. This is like the environment that you might use to write music. That I think is a really interesting and exciting avenue. And actually, for my own kind of as I'm hacking on this myself, I actually have a plugin already that I use locally that will, spin up inside of my DAW and read Elementary that I've written on my computer and process in real time inside the DAW. and I've added little sliders for real-time manipulation of stuff. And that is such a cool workflow. So yes, absolutely. I mean, I think you're spot on, and I definitely want to be able to offer something like that in the near future.
And maybe this is a good segue into understanding like what is the current state of elementary, what kind of broadly things can you do, and then what can't you do that in the future you'd like to be able to you'd like to build.
Yeah, that's a good question. So there are a few features that are kind of missing from elementary right now that I think really need to be there for this to be a viable DSP platform. The first major one is feedback loops. So a lot of DSP involves feedback loops, and a lot of creative uses of DSP involve feedback loops. And you can find that in modular synthesis videos on YouTube stuff, just like creative ways of applying feedback is a whole awesome field of exploration. And right now, elementary does not have sort of a generic notion of feedback. There is a delay element that you can use that can feed back into itself, which is helpful for kind of like a quick implementation of an echo, for example. But feedback in general, in the general case, is something that I plan to get to soon. I mean, it's designed, it's kind of solved, but I haven't implemented it. That's kind of number one. And then number two, I'm really looking forward to hosting VST plugins inside of elementary itself. I think that will be a really neat situation when it gets there.
And from an architecture perspective, is elementary built on top of, or explain to me, like, how is the elementary architected? Like, what is under the hood in terms of the native code that powers the DSP?
Yeah. So, I mean, at the end of the day, like, much of what elementary is Node.js. And so you could sort of think of it as Node.js with this like custom native Node add-on, right? And the add-on is all C++ that I've written up from scratch that will open up the audio driver, on your machine and start working with rendering real-time audio buffers. And then there's this kind of layer that happens inside the native piece for, the render step has happened in JavaScript. We have this new desired state that we have to get to. And there's this kind of like middleman layer for getting there and making the real-time rendering thread aware of these changes in such a way that, you don't have to worry about memory management at the end of the day. You don't have to worry about like smooth transitions for like the way that the audio is changing on the real-time thread, stuff like that. So that's kind of the architecture in 30 seconds.
Yeah, and the reason I was curious is I imagine elementary couldn't run in a browser today, but is there a future where maybe it's possible, especially with like WebAssembly, could this be ported to run in, or some or all of the functionality run in a browser?
Yes, in fact, it's funny that you say that because elementary can run in a browser as of today.
Okay, then I'm wrong. And so, what is how did you, has it worked in the browser from day one, or did you have to port it over? And I'm curious if you did use WebAssembly or what kind of APIs you use.
Yep. So it did not work in the browser from day one, but it was always part of the design that it would be able to work in the browser. And so this is more just an artifact of like the way that I've structured the code repository. Ultimately, there's kind of like the brains that handles the DSP, the brains that handles like interacting with Node.js, and then kind of that middleman brain for, the go-between. And so the DSP piece of this is really quite portable. And that piece I have compiled into Wasm. Wasm loads up kind of inside the Web Audio API, and then elementary can speak to that. Basically, the whole runtime lives inside, a single Web Audio node, and elementary can speak to that. So that's an exciting feature that will be publicly available pretty soon. But I want to get basically a playground up on the website where you can go write elementary, hit run in your browser and hear it right there through the Web Audio API.
Yeah,
that'll be cool when it's ready.
That would definitely be awesome. And can a web browser access a MIDI device? Is there an API for that?
Yeah, there's the Web MIDI spec, which I don't have a ton of experience with. I remember finding it years ago when I was kind of more into the Web Audio API, and I haven't looked at it the way that it will integrate with Elementary yet, but it's kind of an orthogonal piece. I mean, as long as you're getting some kind of like event callback from the Web MIDI API, you could just call elementary.core.render again after doing your Reduxy state stuff.
And aside from running either at the command line or the browser, I think you mentioned earlier, like guitar pedals or a DAW plugin. Like, kind of where is the other places that you see this running and being useful?
Yeah, totally. So in a lot of ways, like the browser and Web Audio or the command line tool that you can use today for running your code are kind of like hosts or harnesses for the core runtime. And the core runtime is totally designed to be lifted out of either of those harnesses and embedded wherever you want it to go. And so I also mentioned the plugin that I have locally for kind of hacking with Elementary inside of my DAW. That is an application of embedding the Elementary runtime in kind of a target stack. And so I could see this going all kinds of places. I'm personally really excited for when it's kind of more broadly available inside of plugins. I would love to see this run natively inside of DAW itself, which you could totally do, or inside some native hardware. I mean, that guitar pedal is a great example. There's a lot of synthesizers these days, like analog synthesizers, which do some of their synthesis or some of their effects digitally in a DSP chip that lives inside the board. Things like that. I'd love to see it start to reach places like that.
And Elementary is on GitHub. It's open source, right?
Parts of it. Well, actually, this is a good question because I'm getting this question a lot. My goal is to be able to open source parts of Elementary, and there's a couple of pieces that I feel are pretty ready to be open sourced, like the library. A lot of that code is, I feel like that should be out there, and I want that to be out there because I think that's a good learning experience for people who are new to DSP. But currently, most of Elementary is actually closed source, and that's sort of an ongoing debate that I have in my head. I mean, ultimately, my goal is to make this as open as I can, but also ideally to build a model around this that allows me to keep working on this and ideally work on it full time. So I want to. I think basically, right now the core runtime piece that's embeddable will be behind like a commercial licensing model. With the goal of generating enough revenue that I can keep working on this. And sort of as that develops, as I hope that develops, as that develops, I want to kind of make pieces as I can open source and get that out there. Because especially with the way that this interacts already with the Node.js and NPM community, I mean, it's such an awesome community. There's so many active people in that community. And I'd love to be a part of that.
Awesome. Well, Nick, thank you so much for joining us today. I've loved learning about Elementary and getting a 101 education to audio coding and DSP. So this has been great.
Yeah, thanks so much for having me.